Hey guys, so for the new digital SAT, we're going to be covering SAT Math, one of the 19 topics that you're expected to know, which is systems of two linear equations and two variables. Please note, mastering algebra is commonly a major portion of the exam, and we're going to go over some concepts and then go into some questions to help you out, and also put a little spin with the new digital SAT. Please note the disclaimer below, and let's get started. So, the way that you solve systems of equations can be through three methods: graphing, substitution, or elimination. So with these three methods that you see here, the thing is for the new digital SAT, you don't really need to use substitution and elimination always, but it can be used in some problems such as open-ended problems. But because you are given Desmos or your digital calculator now to use in both modules, this will be the primary form, graphing. So I just want to put that out there. And just as a disclaimer, I made the following table to help you understand the advantages and disadvantages to using each method. Please note that when you are taking a problem into account for the new digital SAT, it is your responsibility to try to figure out which problem and which method is best fit for the timing that I need. Yes, while graphing might be best suited for multiple choice problems, make sure you understand that open-ended problems might prefer substitution or elimination, which we're going to go over in just a second. If that's the case, go ahead and use that method because that's probably the only method that you could use for very specific problems. So don't feel like you only should know graphing and it will solve out everything when it comes to this topic for the new digital SAT. I just want to put that out there as an additional disclaimer to help you out. So let's start off with solving an equation using substitution and elimination. So substitution and elimination can be used when you have two equations, so equation 1 and equation 2, and you have two variables, x here and y here, and you have to go ahead and solve for both variables or one of the two variables. And so what ends up happening is you're going to use several methods: substitution, elimination, or graphing, but we're going to compare both methods just to give a brief overview. So let's start off with substitution. So in our first equation, x plus y equals 5, we're going to go ahead and switch that over so we get one variable on one side. And this is going to make it easier for us to plug these equation into the second equation. So with that first equation, which is x plus y equals 5, we're going to go ahead and say that we want to bring that x over to the other side. The only way that we can do that is subtract x on both sides. So it becomes x minus x on the left-hand side has to be brought over. So when we look at a problem like that, what we're essentially saying is, okay, we have x plus 5, or plus y, I should say, equals 5. I want to go ahead and bring x over by subtracting the x to then give us y equals 5 minus x, which can be seen in this equation. And then we can go ahead and plug that into our second equation. So with this second equation, what we're going to do is plug in that y into that space, which gives us 2x minus 5 minus x, where we're substituting that in for our y, equals 4. So essentially what we have now in that second step is 2x minus 5 minus x equals 4 by substituting the value of y into the y in the second equation. Now we have to simplify further, so we go ahead and distribute that negative on both of the number and the variable. So we have 2x minus 5, because we go ahead and distribute that minus sign. Minus times minus is going to give you positive, so that gives you positive x equals 4. We're going to combine like terms at this point, and we have 2x and the x together. That's going to give you 3x minus 5 equals 4. Bring 5 over to the other side. Then we get 3x equals 9 because we add 5 to both sides. And then we simplify that further to give us x, or 3x I should say, equals 9, because I brought that 3x down, which is how we got here. And then we go ahead and divide both sides by 3. Therefore, x equals 3. So the thing is, when you're solving a problem using substitution, you now have 3, and you can plug it into one of the two original equations. We can easily pick that first one and say, okay, well, 3 plus y equals 5. Let me go ahead and bring that 3 over to the other side. Minus 3 on both sides, y equals 2. Just some information here. While we did solve for x, please note that if you were given a multiple choice problem in the new digital SAT, to double check if you're solving for the value of x, the value of y, or some sort of combination of both. Maybe they'll be like solve for the value of x plus y, in which then you would go ahead and add 3 plus 2. That's how something like this, which would be considered easy, all of a sudden becomes hard because you have to take that extra step. Now you can see this method takes a very long time, so sometimes elimination might be an easier method. So in this case, let's say that you solve and you go ahead and say to yourself, I'm going to go ahead and add both equations because we're trying to eliminate the y and the y, because positive y plus negative y is just going to cancel each other out because that gives us 0. So then we have to add the other two variables on both the left and the right-hand side. So we're saying x plus 2x equals 3x. And then we say 5 plus 4 equals 9. So what ended up happening in the step of elimination is we're lining up our equation so that all the x's and the y's line up together. And then we can eliminate the variable based on adding or subtracting. Now we can go ahead and say we can solve for x by dividing by 3, therefore dividing on both sides to give us x equals 3. Once again, we could take our 3, plug it back into the equation, and plug it back preferably into the first one for speed, and say that it's 3 plus y equals 5, and go ahead and solve for y, in which we get 2. So now we have x equals 3, y equals 2 for that one as well. So you can notice how long the problem takes. If I had to choose between substitution and elimination, and that was the only way in this specific case, I would choose elimination just because it actually goes faster by either adding or subtracting just to eliminate the y, and they're already lined up. The equations are already lined up. But that might not always be the case. You have to use that chart that's on that first page and try to figure out which method is faster. And that's not if you're using something like graphing. So the thing is, we can compare substitution and elimination. Please note that once again, graphing is the preferred method because you are allowed the Desmos calculator, but you are not always given the opportunity to use a calculator because for whatever reason the problem does not fit in very well, or it's a very complex problem in which you're forced to utilize either substitution and elimination. So this slide just shows us the advantages and disadvantages. Both methods will lead to the same solution, but the choice is based on the specific system and speed, and which one will be straightforward. Substitution can be really straightforward when you have one equation already solved for a variable. So you have to take a look at the equations themselves and compare. Whereas elimination could be faster if you're dealing with really simple coefficients and variables that are already lined up. So let's talk about systems of equations, because when it comes up with systems of equations, which is what we have with the two variables, oftentimes you are going to be using that graphing mechanism. And in that case, you're going to have to find out where the solution is by graphing. So let's say we have two equations and we use Desmos and we plug it in. And then we see that there is a point of intersection. This point of intersection, for example, is -1, -2, -3, -4. -4 in the x direction, y is 0. Then we would say that our x, so this is -4, 0 based on that point of intersection. And let's say they asked for the x and the y. We know that the x in this case would give us -4, and the y would give us 0. So that would be our solution. So the lines are intersecting and they're consistent and they're independent of one another. Now, if there are two lines and they're parallel, which, by the way, that means the first slope, say for example, is 2. So let's say I'm giving m as 2, then it would also equal the second slope of the second graph. So if the first one is 2, then the slope of the second one is also going to have to be 2. So that's just a little hint for you. If they tell you the slopes are exactly the same, like exactly 2, and they tell you that, hey, guess what? There is no solution. That means that they don't intersect. There's never a point that they intersect, which lets us know that they must be parallel, which means that the m of the first equation, or the slope, equals that of the second equation. Now, I also want to point out, going back to one solution, while this might not always be the case, you could have something that intersects at 90 degrees or is perpendicular. So if it's perpendicular, what it means is the slope of the first line is going to be, let's say, m. The second one is going to be -1 over m. So we're talking about negative reciprocals of one another. And m is just my variable that I use to represent slope. So say, for example, we have an equation y equals 2x plus 3. And I told you the second line is perpendicular to this first line. You know off the bat, because it's in y equals mx plus b, that that second slope has to be negative, because this one is positive, 1 over 2. So it's 1 over whatever the m is. The variable x is associated with the number when it's in the form y equals mx plus b. So basically, you have to make sure that the equation is in the form y equals mx plus b, and that when you're solving, the value of m is negative reciprocals of one another to be perpendicular. And by default, you know that there's only one solution. So that's just a little hint for you. If they give you a problem and they say, hey, it's perpendicular, find the solution, you know it's only going to be one. Now, if you have slopes that are exactly the same, and you have the y-intercept that is also exactly the same, which means the lines are exactly the same in totality, then they're going to line up directly on top of each other, which means that they have infinite number of solutions. So if I have one line and another one right on top of it, and that means that the slope is the same, the y-intercept is the same, then it means that we have infinitely many solutions, and that we know that that means that they're lining up on top of each other. They're overlapping. So if they give you a problem, usually they'll say there's one solution, or there's new solution, or there's infinitely many solutions. You're expected to know, as a quick reference, that one solution means one intersection, no solution means that they're parallel, and infinitely means that they're lining on top of each other. And the relationships between slope in all three graphs is imperative to know as well. So let's take a look at what I mean by parallel and perpendicular. So let's say that I'm given an equation, 2x plus 3y equals 6. I have to change it to become y equals mx plus b. So I'm going to go ahead and say to myself, I'm going to keep y on one side and bring x over to the other side. So because it's positive 2x, I'm going to subtract 2x from both sides. Therefore, this is going to bring down 3y equals 6 minus 2x. Now I want to bring y by itself again, so I'm going to divide everything by 3 to then isolate the variable by itself. And therefore I get y equals 6 divided by 3 is 2 minus 2/3 x. Okay, so you might be thinking, what does this have to do with anything? So if we're given something like that, we now know that we have it written y equals mx plus b because we brought over the 2x over to the other side, divided everything by 3. And therefore, we now know that the slope of the first line has to be negative 2/3, which means that if it's parallel, remember, it's going to have the same exact slope. If it's perpendicular, it's going to be the opposite sign. So since that's negative, then the other one's going to be positive, and we're going to take the reciprocal, which means we're flipping it over. So the slope of the second line has to be positive 3/2. So that's important to note when it comes to two linear equations. And this would be an example of when Desmos can't really help you out, you have to solve the problem ahead before plugging it in as a backup. So let's take this into account and try to solve the following question. So I've created this following multiple choice question. I want you to take a moment and read this question. And then once you're completed, please unmute your computer. So mute it to try to solve the problem for a minute. Once you're done solving, unmute and let's see if you got the correct answer. Okay, now that you're done reviewing the question, let's try to see if we got the correct answer. So the correct answer is D, k equals 8/3. And I wanted to show this problem not using substitution and not using elimination, but showing you how you would solve using Desmos. So first, what you're going to do is you're going to plug in that first equation directly in. So that's 3x minus 4y equals 7. Then you're going to go ahead and plug in that second equation, xy equals 2x plus 1/3. Please note if they give you a different letter like C or K, you might want to switch it to K just to be easier. Whichever one you will have, it's going to say add slider over here. So once you add that first equation, what ends up happening is you will see the graph appears. So because this is red, this first line will appear. And we're going to take that second equation and click this button once we've entered that equation, which essentially produces k over here. So to reiterate, you're going to take Desmos, you're going to input that first equation from up top, you're going to input that second equation, even with the variable k, into that second part right here. Remember, we're trying to find the value of k. And so you might be thinking, how am I going to solve that? What does that mean? So we go ahead and say we have to solve where k is going to be the same because there is no solution in this problem. So what that essentially means is we have these two equations. We know in the problem itself, it's telling us that there's no solutions. The system has no solutions. Based on the knowledge previously provided to us, we know that since there's no solutions, that means the line has to be parallel, which also means when we're solving, we don't want to have an intersection, otherwise it's not going to be correct. So we have 4 values of k here. And what I did is once I selected add slide, I get a slider here. And I'm going to go ahead and slide 2/3, 3/2, 4, and 8/3 until I get 2 parallel lines. Now I understand that this is in decimal form, so I went ahead and I clicked enter and typed in 2/3, 3/2. I know what the value of 4 is, and 8/3 to get rough estimates of what it would be in decimal form. And the reason why I did that is because I know that when I move my cursor for k, I have to find a value that is going to be parallel, and I know that value is going to be in decimal form, so I'm going to match it up with one of these since the question only gives it to me in fraction form. And when I go to 8/3, because that is when I had k equals 2.6, that's around the time when I noticed the graphs were not lining up one on top of each other, or they were not intersecting around that value. And that's also what 8/3 is. It's the closest to 2.6. So in that case, I can select D. So this is just a way to solve a problem like this, where you do have 2 plus 1 extra variable that you're solving for. And this is considered a hard problem, but based on the fact that you understand that there's no solution, you can plug it straight into Desmos and solve easier than either substitution or elimination. So I hope that friendly tips helps you out in this video, and I hope that you make sure to subscribe and follow us and click that like button because we're coming in with more videos in the future. Hey, Geeking Out on STEM family, guess what? We want you to hit that subscribe button. Why? Because we'll be producing more content just like this for the AP Biology exam and the new digital SAT exam. By subscribing, you'll be getting exclusive up-to-date tips, tricks, and secrets for both exams. Also, if you're a parent, a teacher, a homeschool instructor, or a student, you might be looking for affordable and exclusive digital products to help improve multiple choice questions, free response questions, or question bank questions related to both the digital SAT or AP Biology exam. We have them here. Make sure to check out our link tree in our bio for curated resources that you won't find anywhere else. These unique resources are designed to help you raise your score. By hitting the subscribe button, the more subscribers we get, by the way, the more videos we can make. So make sure to join our family to ensure that you get a perfect score for both exams. We can't wait to help you succeed.